Hello students, I welcome you all for today's session. In today's session, we will try to understand the origins of XML, how the language is originated, what are the uses of XML, all these things we will see with the help of a video. So now let's go and check out the video.
In this lesson, you will see how the limitations of both HTML and its parent language, SGML, make each one a questionable choice for the future of web publishing. You will also see how XML combines the best characteristics of HTML and SGML to produce a markup language that is flexible enough to handle rapidly changing web publishing requirements. HTML has served the web publishing community well for the few years that it has been around. It is easy to learn, making authoring of web pages a very accessible activity. Even if you don't want to learn HTML, you can still use one of the many software tools available in the market that let you design a page and then automatically generates the HTML when you're done. In fact, HTML's ease of use and the availability of authoring tools are very likely the primary forces behind the proliferation of content that has been published to the web since its inception. In spite of these desirable features, however, HTML has also begun to show some undesirable characteristics as well. The first problem with HTML is that as it has evolved, it has moved away from its original purpose as a markup language. Document markup languages are supposed to specify the structure and meaning of the content in the document. HTML tags like body, H2 or acronym are true to this purpose. They indicate that the content they mark up is the document body, a level 2 heading or an acronym respectively. However, other HTML tags like B, I or TT say nothing about the content they mark up. Rather, they indicate how the content should look on a browser screen. Having HTML tags that specify presentation is a departure from a markup language's primary purpose of specifying structure and meaning. The early presentation-related HTML tags noted above introduced this problem, but it became much worse thanks to the browser war between Netscape Communications Corporation and Microsoft Corporation. Each company kept extending the HTML tag set that its browser could process in an attempt to attract more users. These extension tags like blink and font were almost always presentation related, and their introduction resulted in a glut of HTML tags that governed presentation. The situation motivated the World Wide Web Consortium, or the W3C, to develop the Cascading Style Sheet, or CSS, standard. Style sheets allow presentation information to be contained in a separate file, freeing up the HTML tags to focus on indicating structure and meaning. Now that style sheets are in place, the W3C has begun to deprecate some of the presentation-related tags from the HTML standard. But there are already so many such tags in use that it would be almost impossible to eliminate them completely. This means that new versions of browsers have to remain compatible with deprecated tags so that existing content can continue to be rendered properly. Another criticism of HTML is that it lacks the flexibility to describe certain kinds of documents. This criticism usually arises in the context of publishing a document related to a specific field of knowledge such as mathematics or chemistry. Each of these disciplines has very special publication requirements. For example, a research paper in mathematics would contain equations, Greek letters, and the notational symbols for mathematical operations. A chemistry publication would have its own special needs, such as being able to render complex chemical formulas. HTML, even with its presentation-related tags, is not equipped to mark up this kind of content. As more technical and professional communities look to the web as a publishing medium, it will become necessary to extend HTML even further to handle specialized needs. Or an alternative language will have to be identified for marking up the content these communities seek to publish. A final problem with HTML is that most major browsers forgive mistakes made in HTML code that people write. Strictly speaking, HTML is supposed to adhere to a very specific set of rules called its syntax. Very few browsers check for correct HTML syntax when they process a web page. Instead, they simply ignore any mistakes and render the page as best as they can. It is possible that many HTML documents on the web use incorrect syntax. You never detect these documents though, because most popular browsers simply overlook the errors. This may be fine for users who view web pages through a browser. But it is important to consider what other programs are reading HTML documents. Web crawlers or spiders retrieve and process HTML documents for inclusion in search engines. Additionally, there are browsers that do not render content to a computer screen. Visually impaired users often use browsers that print to a braille printer or that synthesize speech. Programs like these do not have the benefit of a large corporate army of programmers to give them the ability to forgive HTML syntax errors. Instead, they are programmed with the rules of HTML syntax and they expect those rules to be followed. Because of this expectation, they frequently encounter trouble when trying to process a syntactically incorrect HTML document. As the trend towards automated web document processing continues, it will be critical for documents to adhere to proper syntax. Otherwise, it will be impossible for processing programs to correctly parse and render the code. So far, you have learned that HTML has the following drawbacks. It includes a number of tags that indicate how content should be presented rather than what the content means or how it is structured. It lacks tags to mark up highly specialized content typically found in technical and professional documents. Many HTML documents are not syntactically correct, and those documents will be harder for automated programs to process. These deficiencies should be enough to get you thinking about what can be done to correct the problems with HTML. One school of thought is to look at HTML's parent language, HTML, to see if it can be used instead. HTML is a meta-language, meaning that it is a language used to define other markup languages. For example, HTML is a form of HTML that adheres to a specific set of rules. HTML's chief advantage is that it is sufficiently broad and general that it can be used to develop markup languages for virtually any type of document on any type of medium. When you use HTML, you make up the tags that you need to describe the content of your document. This solves the HTML flexibility problem since HTML is by design extensible to any type of content you need to publish. HTML also solves the problem of presentation-related tags. By simply choosing not to introduce any tags that specify how content should be presented, you can stay true to the purpose of marking up the structure and meaning of the document. Finally, SGML can remedy the proper syntax problem because SGML documents are always obliged to be syntactically correct. When you develop a language from SGML, you have to do two things. Choose a set of tags that describe the structure and meaning of your document. State the rules for using the tags that you choose. You declare the rules for using your tags in a separate file called the Document Type Definition or the DTD. When a program that processes SGML requests for a SGML document, it will also request for the DTD of that document and check to make sure the document adheres to the syntax in the DTD. If it does not, the program will give an error message and not process the document. SGML's generality allows it to overcome the difficulties noted for HTML. In the context of the web, however, SGML's great advantage doubles as its primary weakness. Because SGML is so general, it is difficult to write browsers, authoring tools, and other processing programs that can handle HTML code. Additionally, SGML is not particularly easy to learn, especially when compared to HTML. Trying to use SGML for web publishing would be an exercise in overkill. It is too powerful for the fairly narrow context of the web. Its cumbersome nature makes it hard to write programs that work with HTML code. And its steep learning curve means that web authors will resist its introduction as the markup language of choice. Thus, it is unlikely that SGML will become the next prominent web markup language. So far, you have learned why HTML and SGML are inappropriate choices for the next generation of web markup language. In the absence of suitable choice, the W3C decided to create a candidate language of its own. The idea was to retain the flexibility you get with SGML while throwing out the aspects of SGML that have no bearing on web publishing. The result was a greatly simplified version of SGML that the W3C called the Extensible Markup Language or XML. XML preserves all of the advantages of SGML. It is as flexible as you need it to be, since you get to choose the tags you use to mark up the document. Further, because you make up the tags, it is easy to keep presentation-related tags out of the languages you develop with SGML. Finally, XML documents are required to adhere to the rules of syntax published in their DTD. This makes it fairly straightforward to develop programs that pass XML documents. XML also retains the primary benefit of HTML in that it is much simpler to use than SGML and therefore much easier to learn. Using XML will require web documents authors to change their approach to publishing though. Instead of using an established set of tags, authors will be required to create their own tags and to establish a coherent set of rules for using them. When authors publish their XML documents to the web, they will also be required to publish the rules for using the tags in the documents so that XML processors can check for proper syntax. This will be a big change from just using the HTML tag set without having to worry about whether a processing program can understand HTML or not. As you begin working with XML, be sure to keep in mind that every document has two equally important components: the file containing the marked up content and the file containing the document type definition. Without these two components, an XML document is harder to publish, as the DTD serves as a guide for parsers that process the document.
So students, we have seen the video which gives us a brief idea about XML, why XML is used, the origins of XML, and how is XML advantageous over HTML and HTML. So we will continue in the next session. Thank you students.